Have you ever looked at a tiny little computer, like the microbit, and wondered how in the world it can interact with physical stuff? How does it control a light or read a sensor or just make things happen in the real world? Well, that is exactly what we are going to break down today. Let's get right into it.
It really all boils down to one simple question. We know how we do it, right? We flip a switch and a light turns on. But how do you get a computer, a chunk of code, to do that exact same thing? How does it tell a simple light to be on or off, or maybe even somewhere in between? That's the core puzzle we're solving here.
The whole secret lies in these little things we call pins. And honestly, the best way to think about these pins is as the microbit's senses. They are its eyes, its ears, and its hands. They're the physical connection points that let it actually touch and be touched by the world around it.
At its heart, this is a two-way street. The microbit can use its pins to send signals out into the world. We call this writing, to make things happen, or it can use them to receive signals in, which we call reading, to figure out what's going on around it. Writing and reading, output and input. That's the foundation for literally everything. Now, to really get a grip on how this works, we're going to use a really simple but super powerful analogy that just makes it all click: the difference between a plain old light switch and a dimmer knob.
And here it is, the key idea you need to remember. Think of digital as that simple light switch. It's got two positions, and only two, on or off. That's it. Analog, on the other hand, well, that's the dimmer knob. You can turn it completely off, you can crank it all the way on, or you can set it to any of those values in between.
So if we want to get a little more technical, a digital signal is binary. It only has two states. For our microbit, that translates to a 1 for on, which means it sends out about 3 volts of power, and a 0 for off, sending out 0 volts. It's clean, it's simple, there's no gray area. And an analog signal, well, it's the total opposite. It represents a whole continuous range of information. It's not just about being on or off, it's about how on it is. It's all those tiny little steps and positions you can set on that dimmer knob, and that gives you so much more fine-grained control.
So, let's start by looking at how the microbit tells the world what to do. This is what we call output, or writing to the pins. This is the action part of the story.
The most basic command we have is a digital write. This is our light switch. We tell a pin to be either a 1, which sends 3 volts and turns something like an LED completely on, or we tell it to be a 0, which sends 0 volts and turns it completely off. Simple, effective, gets the job done.
But that leads to a pretty obvious problem, doesn't it? What if you don't want a light that's just blindingly bright? What if you want it to be at, say, half brightness? A simple on or off digital write just can't do that. So how do we get that dimmer knob effect? And this right here is where the microbit gets really, really clever. See, it can't actually send out 1.5 volts. It can only do 3 volts or 0. So it fakes it. It uses this awesome trick called pulse width modulation, or PWM. All it's doing is switching the pen on and off, incredibly fast. So fast, in fact, that our eyes just see a dim glow instead of a flicker. It's a brilliant little illusion. So what does this little trick mean for us when we're coding? It means that to control that dimming effect, we get a much bigger range of numbers to use. Instead of just 0 or 1, we get 1,024 different steps of control, from 0 all the way up to 1,023. And here's what that looks like in practice. To solve our half-brightness problem from before, you'd use the analog write command. You tell a pin, say P0, to write a value of 512, which is just about halfway to that maximum of 1,023. And the microbit takes care of the rest, using that PWM magic to make the LED glow at 50%. It's genius. Okay, so we've totally covered how the microbit talks. Now let's flip the script and see how it listens. This is input, or reading from the pins, so it can sense what's happening out there in the world. And just like before, we're going to start with digital. A digital read is basically the microbit asking a pin a very simple question. Hey, are you receiving any voltage, yes or no? It gets back a 1 if the answer is yes, and a 0 if the answer is no. This is absolutely perfect for something simple, like checking if a button has been pressed.
But what if yes or no just isn't enough information? What if you need to know how much? Well, that's exactly where analog read comes in. It doesn't just check for voltage. It actually measures the strength of that voltage and gives you back a number somewhere between 0 and 1,023.
This is essential for reading any kind of sensor that gives you a range of information, like a light sensor measuring how bright a room is. So, we've gone over a lot, but you know what? It really just boils down to these 4 core commands. So, let's do a quick recap and see how they all fit together nice and neatly.
It really breaks down very cleanly. Look, we've got 2 commands for input, listening, and 2 for output, talking. Digital read and write are our on-off switches, working with just a 0 or a 1. Perfect for buttons or simple LEDs. And then we have analog read and write, which use that big 0 to 1023 range, giving us that fine control we need for things like sensors or dimming lights. It really is that straightforward.
And really, that's it. You now understand the fundamental language that the microbit uses to talk to the world. You know how to make it listen, and you know how to make it act. That power is officially in your hands now. If you walk away with just one single thing today, please let it be this. This simple memory trick is all you will ever need to keep these concepts straight in your head. Digital is a light switch. Analog is a dimmer knob. So the only question left to ask is, what are you going to build first? Are you going to start with a simple on-off light switch project, or are you going to jump right in and build something with all the nuance and control of a dimmer knob? The choice is all yours.